Good afternoon, room 10. Here we go. It's science time. Oh, yeah. It's science time. All right. Hey, grab out those science books, open up to page 76. Here we go. We got the last 2 pages of the entire chapter right now. So get those books out right now. Open up to 76 if you're not already there for science class. I got a few pictures up here. We're going to kind of run through. There are same pictures in your book, but just kind of bigger so you can see them as I'm talking about them. Some of you have gotten signed into the Google Classroom. I think I'm going to shoot the sign-in code up here on the board so you guys can find it, write it down somewhere, and get signed into the science class for my classroom. So it'll say, like, remember, you got to click on a little plus sign, and then it will say to join, and you got to type out what the joining code is, and then you guys will be a part of the science classroom for room 10 for me. In there, I think there's maybe about 7 or 8 of you guys in there so far. I know Audrey's in there, Joseph's in there, a few other people. I'm trying to remember who else I saw that had commented in there. So once you guys get signed in there, then you will see there's a whole page for study notes. Because next week we'll have an open book quiz. Open book quiz will probably be maybe Monday. And then Tuesday will be a day where you need to just kind of review and look through the book, check out those terms. Basically, in the Google Classroom, there's a thing that is all of the notes, all of the necessary information you need to do well on the science test. So that quiz will be in the Google Classroom. The test will be in the Google Classroom. All those things will be up there and ready for you next week. Cool. Let's read these 2 pages. We'll crank through here, and then I'll let you guys go, and you can enjoy the rest of your weekend if this was your last class this beautiful Friday. All right. So, I'm going to sit. Hope you're okay with that. Here we go. All right. Let's rock and roll. Concentration and saturation. Here it is. The concentration of a solution is the amount of solute that is dissolved in the solvent. So that's like how much, I always think of Gatorade, right? Has anybody ever bought that little Gatorade plastic? It looks like a mini Gatorade jug. And it's got, the lemon lime or whatever, and you dump the scoops into it, into your water, and you mix it all up. It's like homemade Gatorade. It's never quite as good, let's be real. It's never as good as just buying the bottle of Gatorade. But it's cheaper, but the taste is just never the same. I know, single tear. So, the concentration is how many scoops you put in there. So if it says to put 2 scoops and you put 3, it's gonna be overly concentrated. It's gonna look like that. It's gonna be really strong. Like, woo, that's a lot of sugar in there. It's good. Now, if you don't put enough in there, then it's going to be like the other picture I'm going to show you here in a couple minutes. It's not going to be as strong or nearly as good. So let's keep reading. Let's see. Talked about that. Sweet. So by altering the amount of the solute or the fruit juice powder or the Gatorade, by putting in either more or less, you can adjust the taste to get it right where you want the taste to be. I like sweet, so I'm going to put a little extra in there, you know what I'm saying? Cool. Paragraph 2. If you put a lot of the powdered mix in the water, the solution will taste strong. It will be concentrated. Concentrated means that the solvent is holding more than a normal amount of solute. Now, that iced tea I was talking about yesterday, so when I'm putting all that sugar in there, I am making that thing as sweet as can be. It is super concentrated with sugar. Sweet. So this one would be concentrated. So they used a lot of the red fruit punch mix when they dumped it into this water and got it all mixed up. Sweet. Now, if you just put a little, paragraph 3, if you just put a little of the powdered fruit mix into the water, the solution will taste weak. It doesn't taste like anything. It tastes like water. Ugh. Just kidding. I've been drinking water. Tastes delicious. Kind of. All right. It will be diluted. A solution is diluted when there is less than a normal amount of solute in the water. So let me switch pictures real quick. All right, here we go. This one's diluted. You can like almost see completely through that one, right? That is super diluted. I don't want to drink that. I would drink the other one, and it might be a little strong with sweetness, but I'm okay with that. This one, I'm not gonna drink it. I might take a drink and be like, oh, it's terrible. I'm not drinking the rest of that. You know, I'm gonna pour it out. Be like, Evie, you need to make it better. Put more sugar in it. And she'd be like, I did, Dad. Okay. Now, sometimes the concentration, the next paragraph underneath this picture in the book. Sometimes the concentration of a solution can be adjusted to make the solution more useful. Often a cleaner is mixed with water to form a cleaning solution. To wipe counters and sinks, you might use a dilution or diluted solution with only a weak concentration of cleaner. To clean a very dirty floor, say your floor, like your tile floor, is filthy, you might use less water and use more of the cleaning chemical to get that stuff to come up off the floor. Now, if you continue to add more and more solute into the solvent, the solution will become saturated. This means that the solvent is holding all the solute that it can dissolve. It cannot dissolve anymore. It is saturated. Me drinking iced tea, that iced tea is saturated. It cannot hold any more sugar, yet I still put more in, trying to make it sweet enough to drink. I don't know why I have diabetes. All right, here we go. Now, rate of dissolving. I'm gonna switch pictures here because we're gonna need this one instead. So we got big chunks of sugar, and we got tiny little pieces of sugar. Okay, let's keep going. Now, rate of dissolving, page 77 up the top. Let's rock and roll. Sometimes a solute can take a long time to completely dissolve in a solvent. There are ways to speed up that process, however. One way is to increase the surface area of the solute. This can be done by crushing, crumbling, or cutting it into small pieces. The more solute that touches the solvent, so remember the solvent's the liquid, so the more solute that is touching the solvent, the faster it will dissolve. That is why rock salt dissolves more slowly than a teaspoon of salt does. Now, if you had, so if this was salt instead of sugar, and we had this big, huge rock salt like this, you know, like normally you'll use rock salt if you're making homemade ice cream. You know, you'll drop some of this on the ice around the top as the thing's spinning, and it makes like that glorious, beautiful homemade ice cream. You know, you put rock salt on there, and it helps make it get even colder, so it freezes the ice cream faster. Now, if you drop this in a cup of water, and you have another cup of water, and you pour some, like a whole teaspoon that is equal to the amount of grams that this is, into each separate cup. So one's tiny salt, one's the rock salt, and you start mixing, which one do you think is going to dissolve faster? Do you think this one's going to dissolve faster, or do you think this one's going to dissolve faster? Ben in room 10, what do you think, bro? Which one's going to dissolve faster, this one or that one? All right, give me a thumbs up. Point to this one on your screen right now if you think it's this one. Point to this one if you think it's this one. There you go. Nice. This one. So as you mix them, the surface area of these little salt grains touching the water, the solvent that's in that cup, there's so much more water to surface area of this, is going to make it dissolve much, much faster. You're going to have to stir those bad boys forever to get them to completely dissolve. Sweet. Another way to speed up the rate of dissolving is to stir the solution. So if you just drop it in, it's not going to dissolve that fast. But once you drop it in, if you start to stir it up, boom, it's going to make it happen faster. Like when I make my coffee, when we were talking about that solution yesterday, where I put the creamer inside the coffee and I stir it all up, that helps it spread out faster. If you've ever watched someone pour a creamer into the cup, it's kind of cool. You pour the creamer in and the creamer goes to the bottom and then it kind of comes back out through the top, like up to the top of the coffee. And you can see it spreading, kind of like seeping all over the place. It's kind of like watching fog roll in. It's kind of cool. But usually, you stir it up because you want it to be mixed really well. Now, another thing that can help with solubility and how much of a solute can go into your solvent is heat. So temperature also affects how fast that solute can dissolve. This is because the heat increases the solubility. Now, the solubility is the ability of a solvent to dissolve a certain amount of solute. The particles in a heated solvent are farther apart. This leaves more room for the particles in the added solute to dissolve. So suppose that you want to add sugar to some tea. The sugar will dissolve more quickly if that tea is hot. The sugar does not dissolve as easily in cold tea. Instead, the sugar tends to settle in the bottom of the glass. And that's what I was talking about yesterday. So let me draw that up real quick. Shoot down here. Let's see if I can give us a little example. So let's say this is our cup of water, right? So we've got our water particles. Let's change colors. So we got our water particles all in here, all over the place. And this is cold water. Let's say we got cold water. Here we go, got those particles everywhere. So we got some H2O. It is cold. Sweet. So now if I go and I try to put some sugar in there, we'll say this is my sugar. So my sugar can only fit into the gaps of that cold water to make me sell some good sugar water, right? All right. Now we're going to do a same kind of picture, but we're going to heat that water up. So, oops, got to change the color. So now, this is our warm H2O, is hot water. All right, so these particles are more spread out within the water. So that leaves a whole lot more room for our sugar to fill in. So once you have more room within the water, then you can get more sugar to actually dissolve into it. Same with that iced tea. So you can tell that with the turquoise here, we got a whole lot more turquoise working its way into the liquid versus the cold water over here where it can't dissolve as well. Now, God's care. Here we go. The final last paragraph here. It says, God provides all things for us. Yet we often fail to see the many ways that he takes care of our needs. Even the way matter combines and mixes is an example of God's care for us. So even the way that we're able to mix solutions together, to form things like gasoline so our cars functioning. Just making drinks that they taste good, like we don't even think about that because we're so used to having it all the time whenever we want it. Especially like now with our world in the coronavirus and things being a little bit more scarce, like when you actually have to go without something for a while, you're like, wait, what? I've always had that. Like I should always have that. It's mine. Like that diet soda, man, that Diet Mountain Dew. Hey, I'm cutting that cord. I'm letting it go. I got my water right here. The way God has created all things to work together is absolutely epic. I hope you guys see that. So the science quiz, open book, is going to be from pages, let me see, I believe it's pages 66 to 77. And once again, it is open book. So, do you think you can use your book? Yes, use your book. I know you're smart. I know you're amazing. I know you have just been captivated by these video lessons. But hey, use your book. Take your book out. Take that 2 seconds, get it out of your backpack. If it's not already out, get it out of your backpack and use it. Use it to answer the questions. And I promise you, you will get an E, you'll get an S+, you will do great. If you do not use your book, I cannot make any promises. You might get a U. All right, so make sure to use your book on that quiz on Monday. All right, talk to you guys soon.